So I was just trying to say that I was so happy to hear that the context of the day was indeed the Sustainable Development Goals as overall context. So we'll focus on my specialty, which is climate change, which is one element of context, as mentioned earlier, for the rush towards new sources of critical minerals. And I want to maybe start with a summary in 10 words of the climate change issue. The first 2 words are, it's real. I mean, we know now, I think everybody is convinced that global warming is indeed happening. The second couple of words is, it's us, because it's clear, it has become increasingly clear over the last decades that human activity through the release of fossil fuels, the release of greenhouse gases coming from the usage of fossil fuel mostly, is the main cause of the climate disruption. Experts agree, there's a very wide consensus about this, mostly brought to the world by the IPCC, the Intergovernmental Panel on Climate Change. It's bad. We are starting to see some serious impacts, both for people and ecosystems, and we have seen some impacts on people in Germany and in our country this summer with the floods. But the last 2 words are probably the most important. There is hope. We have the knowledge. It's not only the technology. We have the knowledge. We have the technology to avoid at least the worst climate impacts. So what are we doing? Our atmosphere, as shown here in this beautiful picture taken by the International Space Station, is a very thin layer of gas, which plays a number of very useful roles. And we are using this atmosphere as a free dustbin for our greenhouse gases. And while doing that, we're actually thickening the thermal insulation layer that those greenhouse gases are giving us. And this comparison with an increasingly thick, and you will see it visually here, on the left you see the CO2 concentration, on the right you see the temperature evolving since 1850 in both cases. This comparison with the thickening thermal insulation layer due to that increasing concentration in CO2 and other greenhouse gases helps to understand, without any mathematical model, without any complicated model, why we need to cut net emissions to zero as quickly as possible. Because as long as we don't do that, well, that insulation layer is going to increase. It is as if in winter, when we are cold, we were adding and adding and adding and never stop adding clothes and insulation layer, and at the end we would simply suffocate. And this is what we are starting to do. Another way to look at the CO2 evolution, CO2 concentration evolution, and please note, there's a big difference between the CO2 concentration, which is the amount of CO2 in the atmosphere, which is measured in parts per million. It's a kind of percentage, if you like, and the CO2 emissions. Emissions is a quantity per unit time. We will see that later. This is a concentration over the last 10,000 years. So this is the entire period during most civilizations developed. And for most of that time, 9,800 years, the concentration was pretty stable. And over the last 200 years, after we started to use coal, oil and gas, and also deforest on a large scale, the concentration increased by about 50%. Why? Well, for a very simple reason. We're just adding more CO2 in the atmosphere than natural system. Vegetation and soils and the ocean we're talking about today can absorb. So we are adding 2 times more CO2 to the atmosphere through the release of CO2 through the burning of fossil fuel and deforestation than those natural systems can absorb, and therefore the level of CO2 is increasing in the same way as the level of water in a bathtub would increase if we don't evacuate the same amount of water as we put in. So let's look at a few of the key messages from the last IPCC report published this summer. from the first working group of IPCC dealing with the climate science aspect. This is another look at the temperature over the last 2,000 years. You see how pretty stable with some cooling after the year 1000 and then a very quick increase over the last 100 years or so. We are totally out of the natural variability variations. A number of other parameters have also changed in a big way over the last 1,000 or million years. The CO2 concentration is now the highest in at least the last 2 million years. Sea level is rising at the rates which are the fastest in the last, at least the last 3,000 years. We have gained 20 centimeters already, and we will gain much more, as I'll show you in a second. The Arctic sea ice is at its lowest level in at least the last 1,000 years, and the glaciers are retreating at unprecedented rates in at least the last 2,000 years. A number of extreme events are also accompanying this change in average. Extreme heat, heavy rainfall are the two most important ones. We know that extreme heat is killing. We have seen in the summer of 2003, 70,000 deaths. The summer of 2020 in Belgium, 1,400 deaths, which is a number which is not very well known. The floods, I don't think I need to be very long on that. We know the consequences of that kind of things. So let's look at the future. The future, we can only project, try to do projections and not predictions. The difference between projections and prediction is that for the future of climate, we would need to know, in particular, how the CO2 concentration would evolve, how the CO2 emissions would evolve in the future. And we cannot predict that because it depends on the decisions that will be taken today, next week in Glasgow and in the coming decades. So we have to work with scenarios, and these are the 5 key scenarios the IPCC is working with. From a high scenario where the emissions would be triple those of today, towards, on the other extreme, a low scenario, a very low scenario where the emissions would be zero by the middle of the century and even negative, so it means pulling down CO2 from the atmosphere later. If you feed those scenarios to climate models, this is the global temperature increase you get from 1.5 degrees C above pre-industrial to about 5 for the top scenario. If you look at the spatial distribution, you see that, as usual, the average is always hiding big differences. The continents are warming faster than the ocean, and what's close to the Arctic is heating significantly more than the rest. Changes in extremes is shown here by the number of dots you see. The first dot gives an idea of the frequency of individual 10-year event in terms of heat waves, and you see, for example, for 1.5 degrees C increase, that frequency is multiplied by 4. And then for a 50-year event, so it means for rarer events, which are usually more intense, well, for 1.5, it's a multiplication by a factor 9, just to give an idea. The same is true for precipitation. The extremes increase as well, because warmer air can contain more water vapor, so the quantity of water which falls can be higher, so the intensity of rain is increasing in a warmer climate, and this is one of the factors behind the floods we have seen this summer. Sea level change of interest, particularly when we are in Ostende. These are the results of the 5 scenarios from 50 centimeters to 1 meter by the end of the century. But a novelty of this summer's report is that there is that dotted line there, which shows that there is a possibility. It's a low likelihood possibility, but it's still a possibility because of the ice sheet, particularly the Antarctic ice sheet instability processes, that sea level could rise by 2 meters by the end of the century and would still be rising later. As you can see here, this is for 2300. For 2300, for the top scenario, it would be between 2 meters and 7 meters, but again, with the possibility that sea level rise greater than 15 meters by 2300 would take place. So all the coastal protection plans I think, will have to be revised pretty soon, including in our country. Now, what do we need to do if we want to avoid that situation? Well, I mentioned it already. We need to stop the increase of that thickness of that insulation layer. It means that the global emissions of CO2, remember, there's a big difference between the concentration and the emissions. The concentration is the stock in the atmosphere, the stock of CO2 in the atmosphere. Because CO2 accumulates in the atmosphere. The emissions are what we are putting in it every year. And so this is the shape of the global emissions that the global emissions would need to have in the coming century if we want to stay below the 1.5 degrees C warming set by the Paris Agreement. And as you can see, it's net zero by the middle of the century, approximately. Now, if you look at the emissions, the emissions that took place over the last 150 years. Now I'm talking about the emissions, not the concentrations. This is the shape of what happened up to now. There were, of course, some fluctuations, financial crisis, wars, etc. But overall, the best fit through that curve is an exponential curve with a rate of 1.65 additional quantity of CO2 emitted every year. This is not exactly the shape we just saw that would need to take place. Now, I was asked to say a word about, and it's in the title of this session, about the role of population growth. And of course, behind the strong population growth that we have seen over the last decades, behind the highest emission scenarios for the future, I meant to say, of course, there is some role of population growth. But remember always, and I think another speaker is going to mention that as well, the emissions of CO2 every year are the product of a population in a given location and emission per capita. And then if you look at the ways those emissions per capita are distributed in the world, you see it's quite different. This is a diagram prepared by Oxfam, but it's based on peer-reviewed literature. It shows that the amount of the emissions that's produced by the richest part, the 10% richest part of the world population, is about 50%, while the poorest 50% of the population emits only 10%, with the invert, of the global emissions. So yes, population growth has a role, but the emissions per capita play a very big role as well. Now, the Paris Agreement is supposed to change the trend on which we are. The trend on which we are is that orange curve you see here on the top. The green curve in the bottom is the trajectory, and we're talking about greenhouse gas emissions here, is the trajectory leading to net zero by 2050. Up to now, the result of the plans we have, let's see if I can show you this, the plans we have in the framework of the Paris Agreement for 2025 lead us around here. In 2030, around here, if they are implemented. There was an update to this a few months ago. It's a little better. There was a little increase on paper, at least in the level of ambition, but we are still very far from what's needed to protect climate. So humanity has the choice between staying on the upper trajectory, which would lead to a much less livable planet, both for humans and ecosystems by the end of the century, and even worse later, or to be on a trajectory leading to a warmer climate still, but a climate where some adaptation is possible. I am convinced, and the IPCC has repeated that many times in several ways, that the best framework to look at SDG 13, climate action, Sustainable Development Goal 13, is to look at it in the framework of the 16 other SDGs, including the one which is next to the 13, which is life underwater. And life below water, as you know, I know it will be discussed today, I know it will be discussed even further in the next meeting you will have in a year and a half from now. It's a very important concern that needs to be there as well, and I think it's very important to be sure that the companies who are working in that direction would not be in the same position as Total. If you have seen the Financial Times of yesterday, and if you have heard the news, I'm reading here, Total accused of united effort to play down climate risk. This is because they've not, I mean, some have not listened to the science of climate change well enough. And I think it's very important to do the same for other aspects, including biodiversity. So indeed, we need to decarbonize. We know it's needed to maintain the inhabitability of the planet so that our children and small children can still have a place to live properly. The challenge is huge. It's to transform the world in a few decades so that all activities are decarbonized while the other sustainable development goals are achieved, eliminating poverty, eliminating hunger, providing decent jobs, protecting biodiversity, etc., the 16 goals. And it's very important to consider them as a package because there are so many synergies between them. And it's important to listen to climate scientists, as Greta Thunberg says, but also to biodiversity scientists. Thank you very much for your attention. There are a number of resources that I wanted to show as well, but they are all actually available on this website there from Monday. My slides will be entirely available. Thank you very much for your attention.